The blast furnace is used to extract iron from its ore, which is known as hematite. The temperatures reached in the blast furnace are quite high, with the temperature reaching around 2000 degrees at the bottom and 1000 degrees at the top. Into the blast furnace, three things are added: the hematite, which contains iron in the form of iron 3 oxide, Fe2O3, coke, which is carbon, and limestone. Now carbon, despite being higher than iron on the reactivity series, is actually not a strong enough reducing agent to remove the oxygen from the iron 2 oxide, so we need to make a strong enough reducing agent. So that is the first step of the process. Now hot air is being pumped into the blast furnace through these vents. Now the hot air contains oxygen, which will react with the carbon to produce carbon dioxide. Now once more coke is added, the carbon dioxide can react with it to produce carbon monoxide. Now while carbon monoxide is quite dangerous, it's actually a very strong reducing agent, stronger than carbon. So this is good. We've basically made a very strong reducing agent. And what we can do with this reducing agent is react it with the hematite. So the iron 3 oxide gets reduced to iron, and carbon dioxide is produced. Now what we need to do is we need to balance this equation. So there is a 2 here, and I'm going to add a 3 to the carbon dioxide and a 3 to the carbon monoxide. Now there is an odd number of oxygens here, which means I had to put a 3 here and a 3 in front of the carbon monoxide, so that we have 6 oxygens on this side and 6 oxygens on this side, so that this equation is balanced. Now this is good because this is our molten iron. It is pure iron, and because this pure iron is very dense, it will leave through the bottom. Now the iron that comes out of the blast furnace is also referred to as pig iron. Now this is all well and good, but since we are extracting the iron from hematite, we have a problem. There will be an impurity present. Now this impurity is known as silica, or silicon dioxide, SiO2, and we have to remove this impurity, and this would be the 4th step of the process. Now this limestone isn't sitting around doing nothing. It's actually going to, in the high temperatures of the blast furnace, it's going to decompose. It will undergo a thermal decomposition into calcium oxide and carbon dioxide. Now the next step involves a neutralization. The calcium oxide will react with the silica, the impurity that we want to remove, to produce a single product. Now this is quite a memorable product if you own a calculator or a watch, because it will be Casio3, calcium silicate. Now calcium silicate has another name. It's also known as slag. And this molten slag is less dense than iron, so it will float above the iron and it can be removed. Now, because the waste gases are produced in this process, they'll be removed from these 2 vents, so those will be the waste gases. And the same for that arrow as well. And that basically describes the blast furnace process. Now I'm going to do a quick recap on what we use everything for. So the hematite is our source of iron. The coke reacts with oxygen to produce the carbon dioxide, which will react with more carbon to produce carbon monoxide, which is the reducing agent that is used to reduce the hematite. The limestone undergoes thermal decomposition to produce calcium oxide, which reacts with silicon dioxide, which is the impurity, to produce slag, which can then be removed. Now I just want to note that this is a thermal decomposition reaction, and this one is a neutralization reaction. So hopefully this video has explained something. If you have any questions, drop them in the comments. Thank you for watching.